Welcome to Honors Geometry 8.1, where we're going to start off with polygons and then laser focus a little bit later in the chapter on quadrilaterals. So let's get right into some cool things about polygons. And I don't know if you want to copy this chart or not. If you think later on you need to copy it, go ahead. It doesn't matter to me. I don't think you need to. But let's get right at it. Okay, number of sides. This puppy has 3 sides. What's it called? That's right, it's called a triangle. Okay, this has 4 sides. What is it called? A quadrilateral. And can I fit that in there? I don't think so. I'd love to hear Elmer Fudd say that one. Quadrilateral. That'd be funny, wouldn't it? Okay, this has 5 sides. Washington, D.C. area. It would be called a pentagon. This has 6 sides like a honeycomb. It's called a hexagon. This has 8 sides. It's called an octagon. This has 10 sides. It's called a decagon. Yes, I know there were a couple here I skipped. I did that on purpose. And we'll talk about those in a minute, I guess. You know what? Yeah, we can talk about them now even. Alright, the 2 I skipped were heptagon, which has 7 sides, and a nonagon, which has 9 sides. Alright, look at this. Hept, a lot like September, October, almost like November, December. That's because those used to be the 7th, 8th, 9th, and 10th months. They are not that any longer, but they used to be. Alright, an n-gon. How many sides does an n-gon have? N. Alright, now if I look at this triangle, how many diagonals can I draw from this vertex down here? That is correct. I can draw 0 diagonals because they would all be sides. Okay, on this square, how many diagonals can I draw? Right, you can draw 1. How about on this pentagon? How many diagonals can you draw from that bottom left vertex? It's in here somewhere. Where is it? Can't seem to touch it at all. That's there finally. Yes, 2. From this vertex right here, how many diagonals can I draw? That's right, 3. From this vertex right here on this octagon, how many can I draw? 5 of them. And from on this decagon, from this vertex down here, how many diagonals can I draw? That's right, 7. Now, what is the mathematical relationship between these 2 columns of numbers? What is it? That's correct. This one is 3 less. So if this is the number of sides is n, what would this be here? It would be 3 less than n, right? That is correct. Alright. How many triangles do I form by drawing diagonals? Just the 1 triangle that's there. So the sum of the interior angles of a triangle is 180. When I draw this diagonal, I make how many triangles? That's right, 2. 2 triangles. Alright, 2 triangles worth of angles, 360 degrees. Okay, when I draw the 2 diagonals here, how many triangles do I make? 3. And that would be 3 triangles, so 3 times 180, 540. when I draw these 3 diagonals, I make 4 triangles, and each triangle is worth 180 degrees, so that's a total of 720 degrees. On this octagon, I make 6 triangles. and 6 times 180, 1080. On this decagon, I make 8 triangles. 8 times 180, 1440 degrees. Okay, what is the mathematical relationship between these two columns? Between the numbers? Number of triangles formed is always 2 less, so this would be n minus 2. And then what was I saying here? What was I doing? I was taking the number of triangles and multiplying by what? 180, because the sum of each triangle is 180. So this is n minus 2 times 180. Okay? If this were a regular triangle, what would be the measure of each angle? How many angles? 3. 180 divided by 3? 60 degrees. Okay? The sum of the interior angles of a quadrilateral are 360 divided by 4 angles. That would be 90 degrees. Okay? 540 divided by 5, if this was a regular pentagon, that would be 108 degrees. 720 divided by 6 regular angles, or congruent angles, 120 degrees. 10,080, 10,000, wow. 1,080 divided by 8, each one of those interior angles would be 135 degrees. Okay, 10 angles that have a sum of 1440 and they're all congruent, that would be 1,000, boy oh boy, 144 degrees. And then on this one, the sum of them divided by the number of sides, so this would actually be n minus 2 times 180 all over n. And yes, you'll probably need that right there for your homework. So that one you probably want to copy down, and that's to find the measure of a regular angle. The number of sides minus 2 times 180 divided by n. Alright, by now this should lead you to a theorem. So let's go ahead and read that theorem. Alright, go ahead and write that down. And alright, now that you got that copied down, let's go ahead and look at this corollary. A corollary, again, is a theorem that follows quickly after a theorem. And this is the quad sum theorem, a lot like the triangle sum theorem. The triangle sum theorem says that the sum of the interior angles is 180. This says sum interior angles of a quadrilateral is 360. So looking at this picture here, we would say that 2x plus 90 plus x plus 30 plus 90 equals 180. Now when you go to do your homework, what you're going to see is it might be a pentagon, so you have to figure out the sum of the angles of that pentagon and then write your equation adding up to the correct amount for a pentagon. Alright, let's move along. Okay, the sum of the exterior angles of a polygon is 360. And that just means that it doesn't matter, okay, what is an exterior angle? I know that's what you're asking. Alright, if you look at a polygon, wow, I got a lot of stuff going on behind the scenes right now. My family, for whatever reason, is just making a lot of noise, so I'm really distracted right now. Through no fault of their own, because I'm right in the middle. It's right in the middle of the evening, so I can't really blame them, but I'm being distracted. Okay, when you make exterior angles kind of like that. You extend the sides. Now when I would add up all these angles right here, that would equal 360. Always, whether it's pentagon, an octagon, a dodecagon, which has 12 sides, a nonagons, doesn't matter. This exterior angle is always going to add up to 360. Why is it all 360? Always? Here, I'll show you why. Let's go back to our chart. Notice on our chart that as the number of sides gets bigger, each interior angle gets bigger. Well, that means that each exterior angle must get smaller. Each exterior angle on this regular would be 120. This would be 90. This would be 72. This would be 60. This would be 45. Notice that each exterior angle is getting a whole lot smaller. So that's why, okay, 120 times 3 times 4 times 5 times 6, the number of exterior angles. And it always works out to be 360. This is so crazy. Yeah, I know. It just really is. So that's why the sum of the exterior angles is always 360. Okay? What is the sum of the interior angles of a decagon? A decagon, again, has 10 sides. So what you're going to do is you're going to go 10 minus 2 times 180. That would be 8 times 180. The sum of the interior angles, 1,440 degrees. Now let's work backwards. If a polygon has an interior angle sum of 1,980, how many sides does it have? So you would do n minus 2 times 180 equals 1980. And the easiest way to do this is to divide both sides by 180. So that these cancel to 1s. The left side you still have n minus 2. And on the right side that would be 11. Add 2 to both sides. It must be a 13gon. The number of sides is 13. We'll call it a 13gon. Yeah, after we get past 10 we just skip the Greek and go right to English on the gons. Yeah, I don't know, it's kind of weird. And then when you do number 13 on your homework, make sure you cross out the 2x. That's not an angle measurement. It's a misprint in your book. So if it's not already crossed out, make sure you cross it out. This does conclude Lesson 1. Honors Geometry, Lesson 1.8, Polygons.